Hi there, this is Eugene Blanchard, and I'm building a greenhouse, and in the greenhouse I needed a temperature controller. It had to have two functions. It had to control heat at night, so if it got cool, it would turn on a heater, and during the day, if it got too hot, it would turn on some fans to vent the air. Thought that what would work well is one of these home furnace thermostats. Most smart thermostats will control air conditioning, and they'll also control heating. You can pick them up easily. I picked this off online, a used one. It was for $15. Later, I found that people are just giving away for free. So let's take a look at this one. This one's a Honeywell model. This will apply to pretty much all smart thermostats. They all have standard wiring. Neat thing with these things is they're run just by two batteries, AA cells on, and if you look in the back, you have a wall plate. So the wall plate is separate from the main unit, and the main unit snaps on. To remove this one is you just sort of grab it in the corner here, pull it, and it snaps off. These are the snaps here. When it comes off, it looks like this. These are the inside of the wall plate, so it shows the terminals. On the terminals, you have your green, white, yellow, red, and RC lines. Normally the red and RC are jumpered together. You can see a little jumper here. Let me just take a look at what these numbers mean here. So red or RC, those give from 24 volt AC. So normally you'll have a 24 volt AC power transformer in your house. It also powers your doorbell if you have it. Then you'll have switched outputs. You'll have G is the green wire. The green wire is for a fan. You'll also have the white. The white wire is for heat. That'll usually run your furnace. You'll have a yellow wire, and that's the air conditioner. It'll run the air conditioner compressor. So basically the fan will turn on when you need heat. It'll also turn on when you need air conditioning. Once you remove the wall plate, this is what the back of the main unit looks like. You have a bunch of pins here. The pins here, basically what they do is they go into these sockets here, so then you can have your terminal strip. Now to get this apart, what you have to do is you have to put a little screwdriver in here, just give it a little twist. It comes apart quite easily, and the front display comes off. What's interesting is these are the slots for the wall plate to fit in. They're different widths, so what happens is that you can't accidentally put the wall plate upside down. So once you get your screwdriver in here, there's little snaps. The snaps come off really easy, and this is what the wall plate looks like. This is the display cover when it comes off. It's got these little carbon pads. These are the push buttons on the front. This is the actual PC board with the display on it. It just falls in. There's just two guide pins here. You can easily lift it off. Those little push button pads are just little carbon pads, and they short these switches here. You pull off the circuit board. The circuit board just pulls off, and this is what the sort of the main housing looks like. Here's our LCD display, the front of it. On the back is the electronics we're interested in. What I want to see what was on this board on the back. So you have your microcontroller, you have some capacitors and circuitry, and then you have your relays. Looks like you can actually mount more relays here. So you have 3 relays. On the relays, they actually say 2.4 volts. When I looked up on the model number, it was a Omron G6S series. The one that we had was the G6SK2F. This says it's 3 volts. We're interested in the contact ratings, so the contact ratings are right here. So the rated load is half an amp at 120 volts AC and 2 amps at 30 volts DC. I'm not going to run 120 volts AC. I want to power a heater. A heater is going to be a lot more current than that. So what I'll do is I'll use these contacts to control a 12 volt relay. So if you look at the schematic for it, here's red. What we have is these are relays. This is a schematic symbol for a relay. We have a coil, and the coil is controlled by the microprocessor on the PCB board. So we have 3 coils. Microprocessor is going to control them. These are our relays. One relay is going to control the fan, another relay is going to control the heat, another one's going to control the compressor. So we have red as our common. Normally it's 28 volts AC that comes in, and then all we have is a normally open contact. When this relay energizes, it closes, so we get a circuit. We get 28 volts going out to our fan, or when it closes we get 28 volts going to our furnace, or 28 volts going to our compressor. In my case, I'm going to put 12 volts DC. I'm going to get a little AC adapter, but 12 volts DC, and it's going to go and control. I'm not going to use the fan. I'm just going to use heat and compressor. So on a heat mode, instead of turning on the furnace, it's going to control another relay, a high power relay that's going to control the 120 volts AC heater. This one will go a compressor. So when it wants to cool, what we'll do is close this. We'll have 12 volts DC going to some sort of like PC fans, right? Just for circulation. So basically, we can use this for any time you need some sort of temperature control system. Thanks a lot. Thanks for watching.